My name is Professor Deb Stockbridge. This PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage, published in 2016 by Pearson Incorporated. This presentation is for the C++ programming class at Quincy College, but everyone is welcome to view it. In Chapter 5, you will learn about arrays. Arrays are known as aggregate data types because arrays group data under one name. You will also learn to declare arrays and how arrays can be initialized by using the for loop. An array groups data with the same data type together under one name. The elements are stored sequentially. When you declare an array, the computer looks for a storage location to hold all of the elements in the array contiguously together. The first example, we have an array called letters. It has 5 elements, and it is an array of characters since we have the CHAR. Since the character takes up 1 byte, which is 8 bits, and this array has 5 characters, a storage space of 1 byte times 5 bytes, which would be 5 bytes, is needed. The second example, we have an array called numbers. There are 7 elements and they're all integers. Since an integer uses 4 bytes and this array has 7 integers, the computer needs to find a space for 7 times 4 or 28 contiguous bytes to hold this array. And the last example is an array of miles. These are all doubles. We have 2 elements in that array. Since the double uses 8 bytes and this array has 2 doubles, the computer needs to find 2 times 8 or 16 contiguous bytes. All of the elements in an array must have the same data type. When you declare an array, you also need to list the number of elements in the array. Each element can be accessed using its subscript or index value. It is important to remember that the first element in the array has a subscript value of 0, and the last element in the array has a subscript value of 1 minus the total number of elements in the array. So, as an example, if you had an array named grade with 10 elements, the first element would be grade subscript 0, and the last element would be grade subscript 9. As you can see in this slide, the for loop is perfect for inputting values into an array. Make sure not to try to access a subscripted value which is outside of the array. Unfortunately, if you try to access an element which is out of bounds, the compiler will not give you an error. The computer will look at whatever is stored beyond that array, and who knows what is stored there. Array indexes or subscripts start with 0. The last element subscript value is 1 less than the size of the array. So as an example, we have an array called books. There are 4 elements in the array, and they're all integers. The last element in the array of books is books subscript 3. If you try to access books subscript 4, the compiler will not give you an error. It will access whatever is stored in that location, which is who knows what. One of the ways that you can make sure that you do not try to access something out of bounds of the array is to use a constant to hold the number of elements in the array. Then when you use a for loop, you set the condition to be less than the value in the constant. So here we have max num is set as the constant, and it's set to 3. It's an integer. And then we create an array called desks, and then you use max num there. So then when you're using the for loop, We start I at 0 because the first element in the array is 0. And then as long as I is less than max num, you're going to be okay because it won't go out of bounds. Another way that it makes it nicer to use a constant for the size of the array is that if you are changing the size of your array at any time, you only have to change the constant that you had, in this case max num. This slide shows another way to give values to an array. We have an array called range. It's an array of doubles. And notice that the square braces don't have a number in it. And that's because we're giving it the values. And the compiler is pretty smart. It can count up the values and know how many elements there are. So the syntax for that is after the name of the array and the square braces, you use the assignment operator. Then you have a curly brace, and each of the elements have a comma next to it and have an ending curly brace and then the semicolon. Array elements, as well as whole arrays, can be used as arguments in a function. The first example shows how two elements in the array, this was the array range that we had declared in the previous slide, they can be used, just the elements can be used as arguments in a function, and they're used in the function findMin. In the second example, the whole array, all of the elements in the array called range, are added to the findMin function. And to do that, you give it the name of the array, which is range, and then a comma, and then how many elements are in that array. Arrays are never passed to a function as called by value because they take up way too much space. What is passed to the function is the address of the first element in the array. Remember that arrays are stored sequentially in contiguous memory locations so that with the address of the first element, all of the elements can be accessed. So we also have to worry about, now that they have the address, we don't want to have that function change that array. So what you can do is put const in front of the name of the array in the argument list, and that will prevent the array from being changed. So you can see in this first example, we have findMin, and we give it the name of the array, which is range, and there are 3 elements. So it's giving it the address of the first element in the array range. So in the solution at the bottom, findMin, we put const in front of that array, and then it's going to be a double, and then A would be any array that was passed to the findMin, and then the number that's used. This would be the function prototype for the findMin that's going to receive an array. Searching an array for an element in the array is a common occurrence. If the search function finds the element, then it is returned to the called function. If it does not find the element, it returns -1. So in the example, which is a portion of a program, we ask the user to enter a value you're looking for. We assign it to missing. And then it calls the search function. So the search definition is listed somewhere else. What it says is it's receiving an array called size with 3 elements, and it's also receiving the element that they're trying to look for. As part of the search function, it has returns -1 if it doesn't find the missing element. So if the array is the same thing, if the answer is the same thing as -1, you output it's not in the array. Else, it says list whatever they were looking for, missing, is stored in the array position, and it would give you that location of that element. Sorting the elements in an array is very useful. An array that is sorted makes it easier to locate a given element in the array. So this is the selection sort, where first you look at all of the elements in the array and find the smallest one. And then you make that element the first element in the array by swapping positions with wherever it was located before, now becomes the first element. Then you go through and look for the next smallest element in the array and swap that with the element in the second position in the array. And you continue that until all of the elements are in the correct order.